Hi, my name is Madison Maxey. I have a company called Lumia, and we focus on making smart fabrics for smart clothing and smart soft good products. The sky's the limit when it comes to textiles.
My name is Danielle Applestone, and I'm CEO of Other Machine Company. We build a desktop milling machine. A milling machine takes a rotating cutting tool and moves it through material to create a 3D object.
Under the hood, all computers do the same 4 basic things. They input information, store and process the information, and then output information. Each of these things is done by a different part of the computer. There are input devices that take input from the outside world and convert it into binary information. There is memory to store this information. There's a central processing unit, or CPU, where all the calculations are done. And finally, there are output devices that take information and convert it into physical output.
Let's talk about input first. Computers can take many different types of input, like the keyboard of a computer, the touchpad of a phone, a camera, a microphone, or a GPS. But even the sensors on a car, a thermostat, or a drone are also different input devices. Now let's look at a simple example of how input travels through a computer and becomes output. When you press a key on your keyboard, let's say the letter B, the keyboard converts the letter to a number. That number is sent as binary, ones and zeros, into the computer. Starting from this number, the CPU calculates how to display the letter B pixel by pixel. The CPU requests step-by-step instructions from memory which tell it how to draw the letter B. The CPU runs these instructions and stores the results as pixels in memory. Finally, this pixel information is sent in binary to the screen. The screen is an output device which converts the binary signals into the tiny lights and colors that make up what you see.
This all happens so quickly it feels instantaneous. But to display each letter, a computer runs thousands of instructions, starting from the moment your finger presses the keyboard.
In that example, the output device was the screen. But there are many different types of output which take a binary signal from the computer and do something in the physical world. For example, a speaker will play sound, and a 3D printer will print an object. Output devices can also control physical motion, like a robotic arm, the motor of a car, or the cutting tool of the milling machine that my company makes. New types of inputs and outputs let computers interact with the world in entirely new ways. This has been helped out by improvements to the speed and size of the memory and CPU. The more complicated a task is, and the more information that's input or output, the more processing power and memory a computer needs. Typing letters on a screen may be easy, but to do complicated 3D graphics or record a high-definition movie, modern computers often have multiple CPUs to process all that information, and many gigabytes of memory to store it.
No matter what it is you want to do with a computer, every single action is about inputting information from the physical world, storing and processing that information, and getting some output back into the physical world.